How to find Marshallian demand function and indirect utility function? Question is, assume the utility function is U is equal to Q1 raised power 1 upon 3 times Q2 raised power 2 upon 3, where Q1 and Q2 are the two goods. If the budget constraint is M is equal to B1 Q1 plus B2 Q2, B1 and B2 are the prices of good Q1 and Q2 here. We have to find out the Marshallian demand function and indirect utility function. This question was asked by a person on Telegram channel of econ maths. Okay, so to find out the Marshallian demand function, what is our endeavor here? We want to maximize the utility function, that is maximize the given utility function U is equal to Q1 raised power 1 upon 3 times Q2 raised power 2 upon 3, and we have the budget constraint, that is B1 Q1 plus B2 Q2 should be equal to the income of the consumer. Okay, so to find out the demand function, that is the Marshallian demand function, what will we do? We use the tangency condition, that is we equate the marginal rate of substitution between good 1 and 2 with respect to the prices of the prices of the good 1 and 2. Price of good 1 is B1 upon price of good 2 is B2. Okay, so MRS is simply marginal utility of good 1 upon marginal utility of good 2, and it should be equal to the ratio of the prices B1 upon B2. Okay, now mu1 is simply the partial derivative, and let me write it here, partial derivative of utility function with respect to good Q1, and mu2, that means marginal utility of good 2, is simply the derivative of utility function with respect to good 2, that is dq2, and it should be equal to the ratio of the prices, that is B1 upon B2 here. Now du upon dt means partially differentiating the given utility function with respect to Q1. So derivative of Q1 raised power 1 upon 3 is 1 upon 3 will become coefficient, so we have 1 upon 3, and exponent is subtracted by 1, so we have Q1 1 upon 3 minus 1 upon 3 minus 1 comes out to be 1 minus 3 divided by 3, this comes out to be 2 upon 3. Okay, rather minus 2 upon 3, so we have here minus 2 upon 3, and Q2 will remain same, that is 2 upon 3, divided by du upon dq2 means partially differentiating this time with respect to Q2, so derivative of Q2 raised power 2 upon 3 is 2 upon 3 will become the coefficient. Q2 will remain, Q1 will remain same as Q1 raised power upon 1 upon 3, and Q2 exponent is subtracted by 1, so 2 upon 3 minus 1 comes out to be minus 1 upon 3 here. Okay, so let me write it here, Q2 raised power minus 1 upon 3, it should be equal to the ratio of the prices, that is B1 upon B2. Okay, now what will happen here, let us see. So first we have 1 upon 3 divided by 2 upon 3, so it will become 1 upon 3. If I reciprocate it and transpose it to the numerator, it will get reciprocated. Okay, now here I will do one thing, let's plug this Q1 raised power 1 upon Q raised power 2 upon 3 negative to the denominator. Okay, and this Q2 raised power minus 1 upon 3 to numerator. Okay, so here you can see it will become Q2, let me write it here, Q2 raised power 2 upon 3. If I transpose it here, so we have Q2, exponent sign gets changed when we transpose numerator to denominator or vice versa, so it is minus 1 upon 3, it will become plus 1 upon 3. Same happens with this, so we have Q1 raised power 1 upon 3 here. When I transpose this Q1, its exponent sign changes, so it becomes plus 2 upon 3, and it should be equal to B1 upon B2. Okay, so 3 and 3 gets cancelled, so we are left with 1 upon 2. Here bases are same, powers are added, so 2 upon 3 plus 1 upon 3 becomes 1, so we will get Q2 divided by Q1 should be equal to B1 upon B2. Now and let me write it here, we have Q2 will be equal to q2 will be equal to, so we have transposing this here, so it will become q1 times b1 upon b2 times this 2. Okay, so our Marshallian demand function, that is, rather q2 will be equal to, q2 is equal to twice q1 b1 twice q1 b1 divided by b2. Okay, now to find out the Marshallian demand function, what we need to do, we simply plug this q2 is equal to this stuff into the budget constraint. Here we put the value. Okay, so let me write it here. So we have b1 q1 plus b2. In place of q2 we have this twice q1 b1 divided by b2. Okay, b2 and b2 gets cancelled, so we get b1 q1 plus twice b1 q1. This becomes thrice b1 q1, and it should be equal to the income. So here it is equal to m. Our q1 will be equal to m divided by transposing 3b1, it will get divided. Okay, this is our Marshallian demand function for good one. Okay, so Marshallian demand is when our demand function is in terms of price and income. Okay, we say it is a Marshallian demand function. Now to find out the value of q2, simply plug the value of q1 here. So q2 will be equal to, q2 is equal to, so we have twice q1 is this stuff, m upon 3b1, then we have times b1 divided by b2. Okay, so b1 gets cancelled, so q2 will be equal to so q2 will be equal to, so what will we get here, twice m divided by 3b2. Okay, so these are the Marshallian demand functions of good 1 and good 2. Now to find out the indirect utility function, what we do here, simple thing, we plug the value of q1 and q2 back into our utility function. Okay, so let's denote v. So our indirect utility function is actually a function of, price of good 1, price of good 2, and the income of the consumer. Okay, so our indirect utility function will become, simply plug q1 and q2 into this utility function, we will get the indirect utility function. So in place of q1 we have m upon 3b1 raised power 1 upon 3, and in place of q2 we have twice m divided by 3b2 raised power 2 upon 3. This is our indirect utility function. When the function is in terms of prices of the goods and income, we say this is the indirect utility function. How do we find the indirect utility function? Simply plug the Marshallian demand function of good 1 and good 2 into the utility function to get the indirect utility function. I hope I make myself clear in this video. Thank you.